Thank you. I think you'll find this is a very interesting example that we're going to look at, and that's because we already know that the transform of f of t equals sine of t is 1 over s squared plus 1. But we're now going to show that same thing by evaluating it as the transform of a periodic function. So let's have a look at this. First of all, the period, you know, for sine is 2 pi, so L of sine of t should be 1 over 1 minus e to the s times 2 pi, that's the period, recall, integral from 0 to 2 pi, e to the negative st sine of t dt, and that's just filling in our formula, like here. Now, we're going to focus on the integral here and figure out what this is, and this is one of those that can be done by parts. U equal e to the negative st, and dv equal sine of t dt, so then du is negative s times e to the negative st, and v is negative cosine t. So we've got our integral done by parts is uv, that's this times this, minus v du, and you notice all the negative signs, it actually does come out to be minus s from here times the integral from 0 to 2 pi e to the negative st cosine of t dt. Well, you may recall that in order to do this kind of integral, it takes a little doing. You have to actually wind up doing some algebra. So let's keep going with this. To do this integral, we're going to have to say let u equal e to the negative st and dv equal cosine of t dt, and therefore du is negative s e to the negative st, and v is sine of t. And then we're going to get this, that our integral we're interested in, 0 to 2 pi, is negative e to the negative st cosine of t, that's uv, and then minus, oh sorry, that was what we got before, that was this part, but now we're going to look at this integral, and this integral is s times, there's our uv, and then minus integral of v du, factoring out the negative s, and again I think we wind up with integral v du, and that should all work perfectly there. Let's see, and then we can add this s squared to both sides. See the positive s squared? Actually, that should be a positive right there, so pardon me while I fix this. Okay, I got that fixed. That came about because it was minus a negative, so minus that negative, and then now everything's going good because we do have the signs correct here. So this integral where we're trying to get appears on both sides of the equation, so we can add this to both sides. We get our integral that we seek times s squared plus 1 equals e to the negative st cosine of t minus s times e to the negative st sine of t. But remember, that's going to be evaluated between 0 and 2 pi. And so our integral is going to be that evaluated between 0 and 2 pi over s squared plus 1. So what happens when we put 2 pi in here? Cosine of 2 pi, of course, is 1, sine of 2 pi is 0, so that's going to disappear in both pieces of this. This is the only part that's going to be interesting. We're going to have e to the negative s times 2 pi times 1 minus, I guess if t is 0, it's going to be just minus e to the 0, well, actually minus, and then minus a negative, so plus 1. So e to the negative 2 pi s plus 1 over s squared plus 1. But now recall that when we started integrating this, we had this to begin with. So now we're going to multiply this by the result of our integral, which is here. And when you do that, notice this numerator and this denominator are the same thing, so they cancel out. So you do get 1 over s squared plus 1. And isn't that incredible?
That was very satisfying.
Yes, and very tiring.